Good afternoon, geometry students. I hope that you are doing fantastic. I'm looking forward to doing another lesson with you. We are going to do today lesson 9.4 and 9.5 on sine, cosine, and tangent ratios. So all you need is a piece of paper and a pen or pencil, and you should be good to go. So a ratio is just a fancy word for a fraction. And so we're going to be looking at basically three different kinds of fractions: sine, cosine, and tangent. So we're going to do a little chart here and make a note of what these are: sine, cosine, and tangent. When we talk about a quote-unquote trig ratio, it's basically saying a triangle ratio, which is another way of saying two sides of a triangle divided by each other. So let's put an example triangle here. Let's just call this triangle ABC. So we'll put a capital A, a capital B, and a capital C. The hypotenuse is the side that is across from the right angle. So we will always call that hypotenuse. Now, when we are looking for a trig ratio, we are always going to be considering ourselves to be referring to a particular acute angle in that right triangle. So for example, if we want to talk about the trig ratios of this triangle, we need to think, for example, in terms of angle A. If I want to look at the sine of angle A, I would need to consider the side opposite angle A. So the side opposite angle A is going to be across from it. Sine stands for opposite divided by hypotenuse. Opposite divided by hypotenuse. So let's say, for example, this side was 3, this side was 4, and this side was 5. The sine of angle A would be 3 over 5. Now, cosine of angle A stands for adjacent over hypotenuse. Adjacent is the side that is next to the angle, but not the hypotenuse. So technically, our hypotenuse is adjacent to angle A, but we don't call that side the hypotenuse, we call it the hypotenuse. We don't call it the adjacent, we call it the hypotenuse. The adjacent is next to A, but is not the hypotenuse. So if I do cosine of A, it's adjacent over hypotenuse, which in this case would be 4 over 5. Now, tangent means opposite over adjacent. For this particular triangle, if I was looking at the tangent of A, opposite over adjacent would be 3 over 4. So a trig ratio sounds really fancy, but it's basically just a fraction where you take one side of a triangle and divide it by another. Now, a lot of students use the acronym SOHCAHTOA to memorize their trig ratios. So we'll be talking about that a fair amount. The S stands for sine, the C stands for cosine, and the T stands for tangent. The other letters in SOHCAHTOA help us remember the ratios. So O is for opposite and H is for hypotenuse. So we can see, for example, that sine is opposite over hypotenuse. When we look at the next three letters where we're looking at cosine, cosine is adjacent over hypotenuse. And then tangent would be opposite over adjacent. So that is just kind of a simple way to remember sine, cosine, and tangent. Now, let's do a few examples. I think I'll leave the SOHCAHTOA on the board so that you can have that to refer back to. But let's do, I think of this as a little bit harder of a problem. We'll call this example 1. So example number 1. Write the expression in terms of sine or cosine. So let's say we say the sine of 24 degrees. Let's take a look at what that might mean. If we're talking about sine, we have to be talking about a right triangle. So we can draw a right triangle. We also know that there is 24 degrees here. And so since there has to be 180 degrees total in a triangle, I can subtract 90 from 180 to get 90, and I can subtract 24 from that to get 66. So I know that the three angles in that triangle are 24, 66, and 90. The sine of 24, if we're looking at this angle right here, is going to be the opposite over the hypotenuse. That is going to be, maybe we can call this side X and that side Y. Let's take away the hypotenuse and the opposite labels for now and just call those sides X and Y. If sine is X over Y, I want to think of another way that I could write X over Y. And the way that I can do that is by looking at the cosine of 66. Cosine means adjacent over hypotenuse. So if I'm at the 66 degree mark here and I do adjacent over hypotenuse, that is also going to be X over Y. So notice that it's the same fraction, but I have two different ways of describing it. I can describe it as either sine or cosine. Now let's look at example number 2. This is going to be super easy. Let's say I want to do the sine of 12 degrees. In that kind of a case, I literally just get out my calculator and I push the button that says SIN on it. So right here where it says SIN, I would literally just push that button, push 12, and then push enter. And you'll see that you're going to get a pretty long number. If you want to round it to 4 spots, it would be 0.2079. Now, some of you may have done that and you may not have gotten the correct answer. If that's the case, it's probably because your calculator is not in degree mode. It might be in radian mode. So what you might want to do if you have a TI 83 or 84 is you're going to push the mode button right here on your calculator, mode. And you can see 3 spots down, there's a choice for radians or degrees. You would want to go down those spots and then over to where it says degrees and then push enter to make sure that you are in degree mode and then quit out of that. If for some reason your calculator is not in degree mode, I'd be happy to help you with that during class. Okay, let's talk about example number 3 now. And this is going to be a triangle that we're trying to solve. So example number 3, we're going to solve for X and Y. We have a right triangle and the sides as currently labeled are X, Y, and 8. This angle right here is 36 degrees. Now, what I like to tell students is when we're working with trig ratios, everything has to do with 3. You know, there's 3 angles, there's 3 sides. And so when we're solving a trig problem, which is what this is, we want to be using 3 pieces of information, one of which has to be the angle, and we can only have 2 that we don't know. So we can circle, for example, the 36, the X, and the 8. But we do want to be thinking about what information we're using so that we can now look at SOHCAHTOA and see which ratio would apply here. I've got an angle and a side opposite it, so I'm going to write opposite, and I also have a hypotenuse. When I look over here, I see the trig ratio with opposite and hypotenuse is sine. So I'm going to write that the sine of 36 degrees is opposite, which is X, over hypotenuse, which is 8. I'm going to put a little 1 under here to make it a little bit easier to solve. And then I'm going to cross multiply. X times 1 would just be X. And then I have 8 times the sine of 36. Now, this may look complicated, but literally on your calculator, you type in sine of 36, just the way we did a minute ago, and then hit times 8. Depending on how far you're supposed to round, you might round differently, but if you're wrist rounding to the 10th spot, X would just be 4.7. Now, let's use another trig ratio to solve for Y. So I'm going to uncircle the X this time, and I'm going to circle Y instead. Now I'm going to notice that I'm working with an adjacent and a hypotenuse, so I'm going to see that I need cosine. So I'm going to say the cosine of 36 is adjacent, which would be y, over hypotenuse, which would be 8. Now when I cross multiply, I'm going to get y equals 8 times the cosine of 36. I can take the cosine of 36 on my calculator, push enter, go times 8, and when I round to the 10th spot, I'm going to get 6.5. So now I have solved for both x and y in this problem. Okay, let's go ahead and do another example that's going to be the same basic steps, but a little bit different logistics in terms of the solving. So this will be example number 4. And on this example, again, we have to be dealing with a right triangle because otherwise the trig ratio would not apply. This side is x, this is y, this is 5, and this is 50 degrees. So I want to go ahead and solve now for x and y again. I'm going to solve for x first just because I'm going to go in order of the alphabet. I'm going to circle 3 things, only one of which I don't know, and I'm going to label my parts. I've got an angle, I've got the side opposite it, and I have the side adjacent to it. So I can see here that I need to look at tangent. So I'm going to say the tangent of 50 degrees is opposite, which would be x over adjacent, which would be 5. This one actually is just going to be very similar to what we just did. We're going to have x equals 5 times the tangent of 50. When we put that into our calculator and multiply, we're going to get that x is 6.0. Now, to solve for y, let's go ahead and actually I can keep the 50 circled, but I want to uncircle my x and then I want to circle y. So in this case, if I'm looking at y and 5, I've got an adjacent and a hypotenuse, which would be cosine. So I'm going to write the cosine of 50 is adjacent, which is 5, over hypotenuse, which is y. Now notice when we multiply, I get y times the cosine of 50 equals 5. So this looks visually a little bit different than the last few that we've done, but we're going to handle this the same way. We have to divide on both sides now to get y on its own. So we're still cross multiplying, but we need to get rid of the cosine of 50. Keep in mind, cosine of 50 is just a number in your calculator. So in your calculator, you're going to type in 5 divided by, and then cosine 50. When you do, you're going to get that y is 7.8. Okay, we've got just a little bit more to do here, so we need to keep moving along. Let's do example number 5. Example number 5 is going to ask us to find sine, cosine, and tangent of a 60-degree angle. Now, we did talk about these special triangles before. A 30, 60, 90 has a short leg of x, a hypotenuse of 2x, and a long leg of x times radical 3. Now, the thing that's kind of interesting in this case is because we're going to be dividing the sides by each other, the x's are going to cancel out. For example, if I took adjacent divided by hypotenuse and I had x divided by 2x, the x's would cancel. So all we need when we're doing a trig ratio is we need the coefficients of x. But we don't actually need to use the x. So I can erase the x here, I can erase the x there, and I can erase the x there. I'm going to get the same work as if I had the x, but it's just going to be fewer steps. So the instructions say to find the sine, cosine, and tangent of 60 degrees. Let's look at the sine. The sine of 60 would be opposite over hypotenuse, so that would be radical 3 over 2. Keeping in mind this is opposite, this is hypotenuse, and of course this is going to be adjacent. Cosine of 60 is adjacent over hypotenuse, which will be 1 over 2. And tangent of 60 is opposite over adjacent, or radical 3 over 1. Most people would probably just write that as radical 3. Now we've got 2 more examples. Example 6 is to find the sine, cosine, and tangent of a 45-degree angle. So now we want to use a 45, 45, 90. Remember from before that the legs are going to be the same and the hypotenuse is going to be radical 2 times x. But again, we're just looking for the coefficients of x now. So we can take away the x here, take away the x there, take away the x there. If I'm looking for the sine of 45 degrees, that would be opposite over hypotenuse. Now notice this is going to be exactly the same as if I did cosine, because adjacent over hypotenuse would also be 1 over radical 2. I can't leave the radical in the denominator, so I multiplied top and bottom by radical 2, and my final answer for both sine and cosine, it would be the same, is radical 2 over 2. Tangent is opposite over adjacent, which is just 1 over 1 or 1. So that one's actually pretty easy. Okay, the last problem I wanted to tell you about is example number 7. It's a little bit of a word problem, so I will read it out loud to you and then we'll do most of it on the board together. So for example number 7, it says that Maria is at the top of a cliff. So we've got this cliff over the ocean, and Maria is here at the top of the cliff. She sees a seal in the water. I think I'm probably just gonna draw, I don't know, some weird shape there that this is supposed to be a seal. Not very good at drawing seals. All right. If the cliff is 40 feet above the water, so we're going to put 40 here, and the angle of depression is 52 degrees, what is the horizontal distance from the seal to the cliff? When they talk about horizontal distance, they mean this distance here, and they're wanting us to envision a right triangle. Now, the new vocabulary word in the word problem that I read you is angle of depression. Angle of depression means from a horizontal line going down. So when it says that the angle of depression is 52 degrees, they mean from a straight line, horizontal line going down is 52. That is going to actually end up being the same as what we can call the angle of elevation, which is a horizontal line going up. The angle of depression and angle of elevation are both 52 degrees in this case because, and this is a review of what we learned in chapter 3, we have 2 parallel lines crossed by a transversal, so alternate interiors are going to be congruent. Now that we've done all of this work, we can solve for x by circling 3 pieces of information. Let's circle the x, the 52 degrees, and the 40. And then we have to ask ourselves what trig ratio would apply if I have an angle, an opposite, and an adjacent. We can see that that would be tangent. So I'm going to say the tangent of 52 is opposite, which is 40, over x, which is adjacent. I cross multiply. X times the tangent of 52 equals 40. And then I divide both sides by the tangent of 52. When I do, I get that x is 31. So that's it, guys. I'm super proud of you. Have a good afternoon. Bye.